Now let's move on to the ground truth tool, indicated by the GT icon. As usual, we can load a cube from here and send it to the ground truth tool, or load it directly using the Load Cube button. Let's load, for example, the mini cube that we extracted earlier. In this case, since this loaded cube is meant to be modified by the app, especially its metadata, you can see that it now also appears in the cube list of the application. This is not the case for all tools. You now see the false RGB image here. As in the other tools, you can adjust the image colors using the Image Adjust tab. Next, we move on to segmentation. In hyperspectral imaging, building a ground truth means segmenting the image, where each pixel is assigned a class and a label. There are two ways to perform this classification. You can use a supervised approach, where you manually provide examples of pixels with known labels, or an unsupervised approach, which corresponds to a clustering method such as k-means. In this example, we have two materials, a substrate and an ink. We therefore indicate that there are two classes to identify. You can choose to process the spectra in a non-normalized way or to normalize them, which allows you to focus on the spectral shape rather than absolute values. Let's start the segmentation. This operation may take some time, but in this example, it is relatively fast because the cube is small. We can visualize the result in two ways. Either by looking at the bottom panel, where only the generated ground truth is displayed, or by overlaying the result on the original image in the top panel using the GT transparency slider. Here, we can already see some areas that may require manual correction. For example, we expected to see ink on certain pixels, but they are currently classified as paper. So let's move on to manual corrections. For this step, it is often easier to work with the ground truth overlay displayed with some transparency. To start manual editing, click on Start Selection. Since we want to make fine corrections, we switch to Pixel mode. Right-click on the image and draw contours around the pixels whose labels I want to correct. In this case, I only want to correct the selected pixels, not an entire region. I therefore keep the path open and assign these pixels to class number 1, which corresponds to the ink. I repeat this step by step wherever I think some pixels have been misclassified. I could continue this manual process for all the pixels I want to correct. When everything looks correct, I can now merge the automatically computed ground truth with my manual corrections by clocking on the Merge GT and Select button. The final ground truth is therefore the combination of the automatic segmentation and the manual edits. It is also possible to perform a supervised segmentation. To do this, I click on the Segmentation button, but first I need to enable it by checking the Enable Auto Segmentation option. Before starting a supervised segmentation, it is important to verify that the Selection Enabled checkbox is active, so you can see how many classes you have selected. If you manually selected fewer classes than the number specified for segmentation, you may encounter an error. Always make sure your manual selections are consistent with the number of classes you want to compute before launching the segmentation. For manual selection, there are three modes available: a rectangle mode for large regions, such as a substrate, an ellipse modes, and finally, the pixel selection mode as used before for fine details. In this example, we manually select an ink region and choose to close the path, so that all pixels inside the contour are selected and assigned to Label 1. In other cases, we may want to keep the path open, meaning only the drawn pixels are selected. Once we have selected several regions, we check that everything is consistent. If we made a mistake, we have two options. We can continue the selection but change the label, or we can erase pixels using the Erase Pixel button. The same selection tools can be used to remove selected pixels. Once I am satisfied with my selections, I can run the supervised segmentation. Here, we have three possible distance metrics: cosine distance, Euclidean distance, and correlation distance. Let's visualize the result. In this case, the result is not very satisfactory because we did not select enough representative pixels for each class. It is therefore strongly recommended to continue selecting more pixels manually so that the algorithm can produce better results. Once you are satisfied with your ground truth, you can move on to the next step. After clicking this button, you will see a window with two panels. On the right, there is a table corresponding to a file provided with our database. On the left, a table showing the classes you have selected or segmented in the tool. You can either select elements from this database or enrich it with your own data. Here, we select Pure Carbon Black. This material corresponds to Label 1. We can assign it either by clicking Assign Selected or by right-clicking and assigning it to Label 1. The pixels then take the color defined in the database using the associated RGB values, and the label name and index are stored. If a material is missing, for example a specific paper type, we can add a new label, choose its color, and assign it to a class. We can then save this updated table in CSV format. Note that if you already have our own material table, we can load it instead. Now that colors, names, and indices are assigned for all materials, we can quit this window, and we can save all this work by clicking on Save GT Work. It will be saved as a PNG image and also stored in the metadata of the cube after saving this modified cube to the disk. About spectra visualization in the Ground Truth tool, you can enable or disable the option to display the pixel spectrum at the mouse position by clicking on the Live checkbox. You can also display the mean spectra with its standard deviations of the materials defined in the Ground Truth. Another point that may help in some specific case for segmentation is that you can also select to work with specific spectral bands. When this window opens, you can add, remove, or clear bands. If you add specific bands, you can select exactly which wavelengths to use. Click on Stop Selection when finished, and the next segmentation will only use the selected portion of the spectrum. This concludes the presentation of the Ground Truth tool. Thank you, and see you soon in the next video.